YouTube.
Okay,
If
okay,
you
okay,
follow
sir.
this.
Okay, sir.
Good afternoon. This is Alfie Maria Tom, first MSc Physics student of Assumption College. Hearty welcome to the National Science Day celebrations organized by the Research and Postgraduate Department of Physics in association with Academy of Physics Teachers Kerala. National Science Day is conducted on 28th February every year to commemorate the discovery of Raman effect by Sir C.V. Raman. The day is celebrated to mark the importance of contributions made by scientists towards the development of our nation and the world as a whole. It is used to create the awareness about the role of science in society. The theme for National Science Day 2021 is Future of Science, Technology and Innovation, Impact on Education Skills and Work. A day without prayer is a day without blessing, and a life without prayer is a life without power. So let's start our ceremony with prayer.
जगदीश्वरा ईदासरि कृपये गुणी सदयम् सगलीश्वरा ई प्रार्थना परिपूर्णमायणयो परिविप्रकाशमविन्निना विडरं प्रदीक्षैरागुवा कृपये मुनि सदयम् जगदीश्वरा ईदासरि परिपूर्णमायणयो.
Thank you. Now I invite Dr. Sherin Thomas for the welcome speech.
Thank you, Alfie. Respected Principal, Sister Chargutsuman CMC, Vice Principals, very distinguished resource person of the day, Dr. A.K. Rajarajan, Head of the Department of Physics, Dr. Marina Aloysius, dear colleagues, and all the participants gathered here. Good afternoon, one and all. The real growth of a country lies in the heart, minds, bodies, and souls of young men and women in the country. In order to instill a scientific temperament among the youth, we are celebrating National Science Day, commemorating the contributions of the great Indian scientist Sir C.V. Raman. Every year, the day is celebrated based on a theme, and this year, the focal theme is Future of Science, Technology, and Innovation, Impact on Education, Skills, and Work. With these words, let me move on to my duty of welcoming each and everyone to the National Science Day celebrations 2021, organized by the Research and Postgraduate Department of Physics, Assumption College, in association with the Academy of Physics Teachers, APT, Kerala. Our principal, Sister Rajarajan CMC, is a strong support for the development of science.
No
To
voice.
dear sister. Hello.
Hello.
Okay. On this auspicious day, we are indeed delighted to have an eminent personality and a great researcher, Dr. A.K. Rajarajan sir, as a resource person. He is currently the Scientific Officer G, Baba Atomic Research Center, Mumbai. About his brief profile, Dr. Rajarajan sir took his PhD from Tata Institute of Fundamental Research, Mumbai in 1993. Later, thereafter, as Scientific Officer in Raja Ramana Center for Scientific Officer in the Solid State Physics Division, Baba Atomic Research Center. He was also a visiting scientist in the prestigious Max Planck Institute for Chemical Physics of Solids, Germany. Currently, he is the Senior Scientific Officer in BAR and also serves as Associate Professor in Homi Bhabha National Institute, Mumbai. His area of interest includes condensed matter physics, low temperature physics, superconductivity, computational physics, and so on. He has about 70 international publications with more than 900 citations to his credit. With great honor and privilege, on behalf of the Department of Physics and all gathered here, I extend a hearty welcome to you, sir.
Thank you
I'm-
very much.
I must specially mention here Ms. Sinju K. Rajan, Senior Research Fellow in BARC, who is one of our alumni, for introducing such a renowned resource person for this Science Day celebrations. Our head of the department, Dr. Marina Aloysius, is a strong leader and a source of inspiration for all of us. Her constant support, tireless efforts, and encouragement is the force behind all the innovative programs organized by the department. With much love and affection, I welcome Dr. Marina to this function. I would like to take this opportunity to welcome my dearest colleagues whose support and hard work made this a reality. Now, I would like to welcome our dear students and participants from other institutions for their presence and for considering this as a platform to enrich their knowledge and widen their thoughts. With this, and invoking the blessings of Almighty, let me conclude, wishing you a fruitful session ahead. Thank you.
Thank you, Miss. Now I invite Dr. Marina Aloysius, Head of the Department of Physics, Assumption College, Changanasheri, for the felicitation.
Hello, am I audible?
Yes.
Respected principal of our college, Sister Cheragusman CMC, our most distinguished resource person of the program, Dr. A.K. Rajarajan, and the coordinator of the event, Dr. Sharon Thomas, and all my dearest colleagues and students and the participants from outside our college. Good afternoon to all. When the whole nation celebrates the National Science Day in commemoration with the discovery of Raman effect by the great scientist Dr. C.V. Raman, the Department of Physics, Assumption College proudly joined with the national community in celebrating this great occasion. Though science and technology is a part and parcel of every small things we do, we rarely find time to acknowledge and appreciate its beauty and the role played by the great scientists or great giants in the history who made everything possible. So on the National Science Celebration Day, we pause a moment celebrating the outstanding contributions in science, providing a platform to think and discuss the limitless possibilities of science and technology in growth and development of the nation. This year, in solidarity to the theme, we must more emphasize on the idea of innovative thinking in the field of science and technology. Today's Assumption College, and especially the Department of Physics, is so proud to have with us a really experienced personality who has contributed significantly to the field of science and technology, Dr. A.K. Rajarajan, a personality really apt to share his experience with us today. We are sure that we are going to have a great time with you, sir. My colleagues, especially the coordinator of the program, Dr. Sharon Thomas, and my all other colleagues, and the whole core of our postgraduate students led by Ms. Anakha of second year MSc Physics, was working really hard these days to make the whole arrangements perfect. I congratulate the whole team for working out everything in a magnificent way. I also wish all our dear students and all other participants from outside our college a very fruitful session. Let me remind you that you must make use of this session very efficiently. Thank you. Thank you all.
Thank you, Miss. Today, we have an eminent resource person, Dr. A.K. Rajarajan, sir, Scientific Officer G and Associate Professor of Homi Baba National Institute with us. Your presence is indeed a great inspiration for young research minds, sir. Now, I invite Dr. Rajarajan, sir, to inaugurate the function and to deliver the lecture on the topic, History of Scientific Innovation.
Good afternoon. What do I do for inauguration? Okay.
So, just an inaugural address?
Yes. Respected principal, respected head of the department, and the coordinator, Dr. Sharon. Dear students, ladies and gentlemen, I'm indeed very happy and honored about this invitation. And thank you all for being ready to listen to me. It is a very unique chance for me because I have never given a lecture in Kerala so far. I have given in Tamil Nadu, 2 places, both in a colleges of Madurai where I studied. I studied in American College, Madurai. At that time, ably led by one professor, Rees, R.P. Rees, who was an American missionary and a wonderful visionary also. So I went to Madurai and gave lectures in Madurai, but this is the first time I'm speaking in Kerala. My Malayalam is not all that good because, as I told you, I studied in Tamil Nadu. But I will try to mix as much Malayalam as possible so that the matter in our of discussion is not very heavy. And I hope you will enjoy it. So let me directly get into the lecture and try to share it. Are you able to see the screen?
Yes, sir.
Yeah. So the theme of this meeting is about future of innovation. What way can there be to look at future than looking at the trend? That's one of the very important methods of science, is to predict what happens in future by looking at what happened till that point. Weather prediction is done that way. Okay, so let me use this scientific method to tell you what happened in the future in the past, every point, what was its effect in the future, and what could be the effect, and what we can do from this point onwards. So the topic of my talk will be history of science innovation. Okay, and let's go ahead and first of all find out where we end. How do we do science? We do science with our knowledge, with our mind. A man is the one with his extraordinary mind. Almost all philosophy says that man has a rational thinking. He has power to think. He has power to predict. He can understand more. He can remember more than other animals in the world. So a man is known for his mind, and mind is the vessel of knowledge. So is it only a vessel of knowledge? No, it is not only of knowledge. It is also a machine of innovation. It finds out new things. It understands the world and generates knowledge. And it makes things, it generates inventions and produces more knowledge. The knowledge and innovations are inevitable part of human life. I just want to see innovation is a part of everybody. Anybody can innovate. A mother who prepares a child to go to school will find any number of ways of making her comfortable and put her in the bus. Those are many inventions many people tried. It's commonplace. Invention or innovation is very commonplace. Here I want to tell one of small stories of my teacher's son, Benny. He was just 3-4 years old. Suddenly, while walking on the street, he says, "Benny, your idea." So, father asked him, "What?" "How about buying an ice cream, eating and walking along?" The idea is good, right? It is a very innovation. He saw an ice cream stall, so he invented an ice cream. So the way innovated was good. That innovation is commonplace for in the human society, but it is very difficult to find out at what point the innovation becomes non-commonplace, much more widely applicable, and even more useful than just applicability. It is even profitable. Kenneth Oakley is he has called man for this reason to be a tool maker. Now, what is the relation with innovation? Knowledge is what we have, what we innovation, what we can do. So knowledge is understanding of the nature. Innovation is expression of that knowledge. We express our knowledge by innovating new things or inventing new things. Now, is that the only thing about relation between knowledge and invention or innovation? Image is a feedback mechanism. When we want to invent something new, the invention forces you to learn new things. The innovation gives you a feedback. Your knowledge is not sufficient. Go and learn. Here is a picture of a machine that Joule used to find out what is the relation between mechanical work and heat. By that time, people knew that heat is a form of energy. So he was finding out the relation between the mechanical work and heat. This all you know, the mechanical equivalent of heat is 4.2 Kelvin or some such thing. Okay, so his job was very boring, actually literally boring. He was boring the Canon.
Excuse me, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, the slide is not changing.
Slide is not changing. No,
Yeah.
not changed at all. Can you see knowledge and innovation? Can
No,
you see?
sir.
What do you see?
Only the first slide, history of scientific innovation.
Okay, now do you see?
Now it is visible.
Okay, then I will go in this mode.
So can you maximize that? Sir, it's not in the slide view mode.
No, it is not. If I put in the slide view mode, it doesn't advance.
Okay.
That is a problem. This I know there is a problem with Google. Can you see the slide changing now?
Now, yeah.
I had shown this slide as the man of knowledge, and I shown this slide where good idea story. Okay, and I am showing this slide when I show that knowledge and innovation interact with each other. While knowledge creates innovation, innovation adds to your knowledge. This is the slide I showed, and here this is the slide I'm showing when Joule's work on he's actually literally boring work because he was doing the cannon hole muzzle to produce a rifle's groove on that. It's literally boring. You have to cut it out and mill it out, and this process produces a lot of heat. He had to pour a lot of water and cool down. So he had to find out how much water he will have to pour because he was in the engineering corps of the military. So this knowledge made him understand the relation and quantify it, that this much of mechanical work is equivalent to this much of energy. Okay, so this is an example. I just took a slightly out of the ordinary example to show how invention supplements your knowledge. Okay, so now is the slide changed? Excuse me, is the slide changed?
Yes, sir.
Okay, so philosophy, the ancient science. That's the science. Okay, now the knowledge. What is knowledge? Knowledge is not only science, right? We know all that. In ancient days, knowledge was anything that the human mind could think of, and result of any thought that was useful to others. Okay, and invariant in another mind. Okay, which is invariant in another mind. That is, I have a kind of thing. I look at some observation and I have a kind of thinking, and the another person gets a very similar kind of thinking. We both agree, then that becomes knowledge. So knowledge is anything that what human beings can think of. Okay, and the knowledge becomes society's knowledge if it is agreeable to many people, and there is a social understanding that this is a knowledge. These are all some knowledge was not any time located in any place. It was widespread. And we don't know what is the ancient of is today. Is we do have a lot of Indian knowledge and innovations of India. We have all these names: Kannada, Aryabhatta, Brahmagupta, Bhaskara, Varamihi, etc. Whereas we learn a lot of Greek, Ptolemy, Archimedes, artists, and all more because of the political turmoil which Greek people came to all the way to India and tried to establish the reign at that time, which essentially destroyed a lot of things. The political turmoil always changes the face of knowledge. Most of them removes the records of the previously existing knowledge. What we have is only a very small part of what is left over. But even that is very mind-boggling. look at Canada had the idea of atom, which was only finally convincingly approved in the beginning of 1900 with Einstein's discovery of Brownian motion. Einstein's theory of Brownian motion. Till then, it was not accepted to the extent that the person who had the kinetic theory of gases, Boltzmann, gave is to be in one single line. Boltzmann gave the statistical mechanics in one shot by giving his the formula for entropy. So, but it was not accepted during his time, and later when Einstein gave an expression for the Brownian motion, that's when it's. But such and philosophy existed in a very long time ago. Descartes also had similar idea of atom of matter, and philosophy we are going into innovating in agriculture, construction, medicine, and mostly, and that need to communicate between one area in India and area in Greece. And I'm preparing to get a lot more of data. No, Varahimira, who's a rishi or scientist, knowledgeable person in Ujjain, learned Greek so that he can learn from people. Okay, so that hard learning and searching for knowledge existed. This is a human nature. So we need to. Okay, I have already said this before, that the innovations that were engine knowledge were on agriculture, architecture, medicine, trade. Innovation was not very easily accepted by the society, because when you try to tell someone something, may not agree with you. They may not agree with you for many reasons. So the society has to come to an agreement, and then the innovation has to be put in place for a common use. This process is the one which makes both ways, makes innovation difficult. On the other hand, it also makes innovation useful. We will see that in the next few slides, and we'll also see how that method changed over time and where we stand today. This will be the content of the talk, with a history of Sir C.V. Raman in between. Now, here is the old time in innovation. Very surprisingly, two of them we can easily identify. One is this pyramid, the other one is aqueduct. This is aqueduct carrying water from one place to another, was built by Romans. But these two are very extraordinary for their time. This one is a machine or a device, earthquakes. Earthquakes took place very far away, in which direction, how far away, can found out using this machine. And the details, because if you are interested, if you remember at the end of this talk, most of the things which I leave without explanation are available in Google. You can go in Google and search for it. This picture you will find, and you can find a lot more information in much more clearer. So I will not be going into such boring details, which you can get from Google. I will try to give a perspective of today's talk in a different way, which is not available in Google. Okay, so here stops our introduction as to what is knowledge and what is innovation and what is society in olden days. Till now I have not explained. Society's take in managing this knowledge, and innovation is so common, it needs managed, and the society did manage it. How did the society manage this? Society managed this using patenting law. Patenting is a word which comes from a very crazy usage. Patent paper, patent letter actually. Patent letter actually in English means an open letter. An open letter given the ruler or the government to a person, saying that the person has special privileges. So, for example, you give a letter saying that you own the land which is south of all this area, for so much area is yours. That used to be the ownership kind of a letter. It's an open letter from the king or the ruler or the government to that person. This is called patenting letters. Such patenting letters were given even during our Greek Roman time for various innovations, mostly culinary innovations. If somebody makes a very delicious food, they could go to the king and then tell that I have made this food, I want to sell this food, and it should be protected. Nobody else should sell it. So the king gives an open letter saying that such a letter you can see in this slide here. This is one of the very ancient patent given to somebody, and I have not read it fully. Just internet. This kind of a letter the person carries, and he allowed to use that technology, or we call it technology today, or that method for a specific amount of time, and that will be protected by the government. Okay, this was called patenting. We all know about patenting as it stands today. It stands at a much more advanced level. The patenting was a right of the society or the king or the ruler or the government. So in our country, the government is an elected government. The government has officers of certain level who will decide how to and when to or whether to give the patent or not. This patent also almost always generated a lot of money. So when the government gives a patent to a person, gives money to the government in return, it will be normally a part of the profit that person gains from the patent that he has obtained. It could be for anything. It could be for owning a particular thing. It could be say one day morning that says this particular person only can fish in this water. Even that kind of patent given. So this is how the patenting, the society way of innovation, and it that we are talking about. The next one, patenting laws were much better. Okay. When by innovation and even Archimedes invented how to measure the volume of it, and and he obviously wanted that method to be usually by. So the older patent said only he can use it, others couldn't use it, and he will do that for others and make profit. So, but in medieval law, the things people had to give something new. And even not any charges were they got some kind of profit. So only so became a station for business. So if you want to create a business, go to the ruler and ask for a patent, and they give you. During this medieval patenting law, or people lived such times: Nicolas Copernicus, Kepler, Galileo, Newton, Robert Hooke. Newton and Robert Hooke were, with each other for the same, but suggested the law first, the gravitational law. And Newton made it more quantitative and wonderful law of inverse square. So it was credited to Newton and Robert. Both of them were great people in the government at that time. Newton was warden of the mint. He made mint, he made coins government. And Robert Hooke was sir, at the high level of decoration in the government at that time. And so Robert Hooke's, he also lived in that time. During this time, all their ideas were patented and controlled by the government. But all these people were also very close to the and very in proximity to government, and that is one of the reasons they could get the patent also. Okay, and during this time, other things which developed, physics developed, astronomy developed very clearly, which were even today good portion of Boyle's law is even today, right? Robert Hooke's law, you know about the elasticity law. He was actually an engineer. The elasticity and strength of materials law is even. But at that time, the chemistry was all that good chemistry. Chemistry was, and almost every party was trying to make gold materials, including Newton. Newton tried his hands on alchemy. Even he became warden of mint, and he tried to make. People say that Newton died out of that. I will not think we'll go in that direction. But alchemy and geography also prospered, because the patenting laws have started in which area and this kind of control over what created a political boundaries. In geography, also developed to find out the how the terrain looked like, how the landscape changed, and how it will change, etc. This medieval period patent also prepared humans for technologically advanced. By that time has measured he has measured time, he has realized acceleration on any perspective of their mass is the same, and using the pendulum, Galileo has a third of pendulum was later more accurate clocks which we got these days. So the people have moved over and have to here I use the weather nature of the nature. It's at 4 o'clock, so in summer it's but in the north is where Delhi, northern, they have not the prepared logically advanced. From 1700 onwards, the laws became stringent. The political turmoil in one place to the other created wars, and war started driving, right? And even before 1700, the war started driving the science and knowledge. How to throw an object too far away as much as possible, down to the other fellow's side. Okay, all those things became good science and mechanics, and carrying things and moving things, vehicles, all those things started becoming important for political advantage. But in 1700 onwards, this is 1700 onwards, we have a new. Before we go further, I will go into the new regime. 1700 onwards, laws became more stringent. You could not go with any idea to the government and say, I want to patent this law. This is my innovation. This is innovation I want to patent. Previously, they did not bother. You want to patent that, you can do this, and give them that patent. It took a lot of money. But then the law changed. Even the ruler have to start obeying the law. The politics has changed. Right? The ruler also start obeying the law. They're more stringent. Now they say, no, take anything what is available already and then patent it. You have to come specifications for conditions. And here it is again, though the earlier whereas it was only a support, here the patenting, innovation, inventing, everything was totally propelled by war and political turmoil. So that's why I put a picture of a gun here. And this also not just innovation, the idea, the method of making, the industrial method, everything had to change. Everything has to be changed. You have to make things very fast. It is not sufficient to wait for 3 months. Okay, you will get your product. Previously, you make a furniture, the fellow will come after 6 months. I have bought the wood and I will chip it and make it. After 3 months, he will come. I made one, I made two. It's not possible. I want a furniture made within just. So it became industrial. So this not only was propelled by political, this also come the beginning of industrial revolution. So actually, patenting law, innovation, management of innovation, aided intent, making the innovation useful for people. Obviously, it was that time, most of the use was unfortunate. war, but there were a lot of war also. Okay, very powerful nation, States of United States of America became a democracy, and they have become a law-driven country. Till then, there was only one country which is with so much of difficulty has become democracy. That was France, and all other countries were still ruled by kings and monarchs. Um, so France has become sort of started ruling by the revolution people, which was setting up a democratic government. But this government became completely democratic, and they started forming law on a democratic way and for the people rather than for the advantage of certain set of people whom they call royals. There were no royals, etc. And the US patents more protect because it opened its own patent and in its own land, and its patent in Europe also, and China also, and Japan also. Okay, so as long as law allows that US patent will not be dishonored in another country, their country's product also could be sold in this country. So this bilateral nature came through this product, so that if there is a product which is patented in US, it could be easily sold in Japan, and if there is a product patented in that could be America. One thing which we don't learn in history properly is the Americans were at really trouble with the Japanese imported product before the World War II. Japan was almost taking over the market of America, and interested in buying Japanese products because they were cheaper. Right? Like we are today trying to Chinese products which are cheaper, and economy is a very important part of trade. So the US patents became, not only US patent became valuable, US as a country became more well sought after country. People moved, and then US allowed people to move. Very, very intelligent people, very knowledgeable people move to their country and start being there and start contributing to the wealth of that country. Now, US involvement and their improvement of patent laws reflected in other countries' patent laws. Because trade has to be maintained, the parity among the intellectual property rights also have to be maintained. So in order to do that, the developed patent laws in US also reflected in Europe, China, and Russia. Also, Russia did never enter into US for patenting law, etc. Never accepted a patenting law from US. But US adopted this patenting law, and then intellectual, not only happened by the government, has become property. Right? Before, if I wanted to, for example, Alfred Nobel, if he wanted, he could not own the patent for making dynamite. Right? He made a way of making safely dynamite and unsafely exploding it, and he became very rich by, but at that time he could not sell it to somebody else. He had to do it himself. The intellectual property rights comes to a different story. I have and I can sell it at any price of whoever has to be there. So this intellectual property became a hallmark development in the management of innovation. How do we, if I have an innovation today, I can make a new way of bullet. I don't have, whether I will make actually a bullet. Do I have a company to make it? Do I have a factory? Can I get people? I don't have to worry about it at all. Who is Smith and Wesson, who makes a bullet for the thing? You say if you make a bullet like this, 80% better efficiency. So you use this, you give me So they buy it from you. Even today, all these companies, they buy patents from um, other companies to make, or Tata company sells their patent to other companies as well. Similarly, I heard some sad story when I was in Germany that BMW lost a large number of patents, so 400, 500 patents to Hyundai when they separated the. They had a collaboration for making cars in both Germany as well as in Korea, and the company fell off. When they separated, the writing of the law, writing of the contract was not proper. So BMW lost a huge amount of contract or patents to Korea. So now it is your idea has some property, and on paper finds a world. What it is in this world? Let's look at these scientists and innovators. And Alva Edison, we know about him. He's one of the very figure of a large number of products which were like light bulbs, etc. One more invention is coming in the next slide. Nicolas Tesla, who was actually Thomas Alva Edison's co-worker. Actually, he was working under Thomas Alva Edison. I'll tell you a small story quickly as to how this support from the society comes, and how a better innovation is a story between Thomas Alva Edison and Nicolas Tesla. Nicolas Tesla was working for Thomas Alva Edison, and Nicolas Tesla has just migrated from Croatia to America and was an extremely wonderful scientist. Okay, so when the municipality announced that the city needs to be electrified, Thomas Alva Edison had a model which he will patent and give it to the municipality for electrifying the town. Okay, the entire town need to be electrified, so you need to have some generator and electricity should reach each houses. Nicolas Tesla came up with a better idea. Thomas Alva Edison's idea was on a DC, that is direct current. It involved large voltages and things like that, whereas Nicolas Tesla came up with a wonderful idea of alternating current, which costed 1/3 for the company. And Thomas Alva Edison did not want to change his ideas. Told Nicolas Tesla, you come up with of this who accepted, he did not keep his promise of doubling his salary. He only increased the salary a little bit. Nicolas Tesla had a big fight with him and left the company. And he went out and gave the quotation on his own, and we know the result. Today we have alternating current 50 hertz and 60 hertz in United States. It's all Nicolas Tesla's ideas. Nicolas Tesla had the alternating current motor. So entire alternating current technology was developed by Nicolas Tesla. Rudolf Diesel and Fleming and all, you know who Rudolf Diesel as the automotive. Haber is a chemist, a wonderful chemist who was completely by the German government, the king of the German, and he's one who had the ammonia, discovered the process of making ammonia. You should read this Haber story. It's a very interesting story of mystery, murder, and a lot of scientific discovery as well. And if possible, if you read a little bit further, you will find Haber and Einstein had a very good interaction, very bad action sometime during their millennium. Alexander Fleming discovered penicillin. Marie Curie, obviously, Marie Curie discovered radium and radioactivity. And among these people were C.V. Raman. He was also born in 1857. I will have the number correct. And C.V. Raman was born into this society of intellectual property rights. The science was advanced. Like it is advanced, always advancing. Science is always, it is not like a wave. it keeps on advancing. It may be like a wave, but the wave never recedes. It keeps on advancing. You are born into the present situation, and if you're looking at future, you don't know where you are going, but you go start from where you are. That is the lesson number one. If you are in a field of research, and if you're in a field of pursuit of knowledge, and if you are in a field of developing new technologies, you don't know where you're going, or you know only to some extent where you're going. What it will result in depends on your companions and how the society will support you. And into this kind of a world, C. Raman was born. And let us see who were the other people with him. Who were Raman's companions? Raman was born 1888 and he lived till 1970. And Edison was doing stuff. Edison was there. So Thomas Alva Edison was well known to him. So you see the kind of innovator he had to compete with to make invention seen. Okay, with this kind of Einstein was there. Einstein was there very much, just 10 years younger to him, in Germany. And along with Einstein, there were giants of science. And it is at this time, this very young Raman, at the age of 16, writes his first scientific paper and publishes Nature. Okay, today Nature is a dream for me too. If I submit a paper in Nature, oh, wow, wonderful. I will be very happy. But at that time, Raman published his paper in Nature. As soon as the Nature appeared, he became famous among European scientists. Europeans already knew that, and Raman also considered moving to London, and because of his health, probably will go bad if he goes there. He may get TB, so he did not move to UK and continued in India for our good luck. Who were the other interesting people with Raman? With Raman was Arthur Conan Doyle, writing stories of murder fiction, murder mysteries, and Tagore's poetry were coming in cylinders. What are these cylinders? See, yesterday's method was, and before there was magnetic tapes, and before, this record player, a disc. The cylindrical form of this disc is, you can see here that brown stuff. The one which is called a cylinder, and Tagore's and songs used to come on that in Calcutta when Raman started working there. This what I told you before. Thomas Alva Edison had the patent and developed and made and sold to the world. This has no electronic component. It is just mechanical, needle going up and down in the grooves and producing mechanical vibe amplified by this megaphone. Very simple process. It appears to be a very simple process having no electronic instrument. But okay, today's technology is a lot different from those days' technology. But this was the state of art. What did innovation do? Innovation at that time also, innovation catered to humanity. People like to hear songs. There are a few people who are gifted with melodious voice and wonderful theme, wonderful expression, and nice way of singing. And their voice could be heard by everybody else. This is the humanity which this invention served. Let's go one step further. What are the inventions at the time of C.V. Raman? Internal combustion engines were also. Discharge tubes were available in some laboratories or the other. They were studying the spectrum of discharge of various gases and things like that. Radio communication was there already. Marconi had finished his patenting business, and then radio stations started coming. Telephones were also there. Probably they were trying to connect the with laying a cable under a transatlantic, maybe not less. Not less be possible to do. How it goes further is depending on how useful it is to the society. telephone. People wanted to go up and down, people wanted to communicate, and that the telephone helped. X-ray, okay, X-ray is an extraordinary application, but still, that was the first Nobel Prize which was given to Röntgen, and relativity by Marie Curie, and she also had radium and polonium. By that time, the chemistry had become chemistry, maybe 50, 60 years ago, even chemistry, and people have started using atomic number instead of atomic weight. Till then, the periodic table was written on the basis of atomic weight. By that time, the science had developed. I will tell about the scientists at the time of C.V. Raman in the next lecture. So science has developed to the extent of understanding atom. Here, the innovation gave rise to more knowledge. The innovation of spectroscopy of gases in a discharge tube that gave structure to the atom. And people knew about atoms, and then the atomic number was started in the year 1940, 1910, 1940. Okay, so till then, atomic weight was used. Sorry for the very bland slide here. This is science during Raman time. Science had a slight change of phase, not slight, quite a lot. It had actually curdled into two parts. One part is that of theoretical science, the other is applied science. Theoretical scientists like Max Planck, he's the beginning of quantum mechanics, right? He's the one who said light quanta, and people were not believing, but he was a top professor in Berlin until he retired. And he was also mentor of Einstein. He protected Einstein from all, including Haber. I told you should find out about that. The rest of the faculty and rest of the world max support because Einstein's theory of relativity, special theory of relativity, and the general theory of relativity were brought up by Max Planck's support. And Schrödinger, Pauling, Linus Pauling in chemistry, all these people were there to give a theory of science. The science developed totally on theoretical basis on these people, and it is at this time this very Indian man goes and gets a Nobel Prize. So let's quickly go through how he did that. He was born in 1888, we saw that, and he was born in Trichy, not very far from China City. If you go through that Ghat road, you can easily reach probably through Theni or probably through Trivandrum. In about 12 hours, you can reach that place, Tiruchirappalli. I have been there. I lived in Tiruchirappalli when I was 7 years old or something. Studied in 2 schools there. And yeah, it is a very, even in the time when I studied, it was not a big, it's not a city, it was a town. It was a better developed town. And C.V. Raman was born there, and when he was 3-4 years old, his family moved to Hyderabad, and his father was a professor or school teacher. And hence, knowledge and learning was a method of the family. C.V. Raman was an extraordinary student. He finished all his, those days there is no age limit. You don't have to wait until you are 15 to pass your matriculation. That is 10th standard. He finished it at 9 and 11 and then entered college at 15. Okay. And he finished his BA. And the whole idea of doing all these was not working on science, though at the age of 16, he has put a scientific paper. Even those days, the best sought after job was being a civil servant. Remember, India was under British rule. Okay, so Raman was a civil servant in British. He passed and became something and pass IAS exam. You become assistant collector in a district wherever posting is there, you will be posted there. You will have to go and you can take up over the post as an assistant collector. And similarly, if you are in the revenue department, you will go and take up as poster your post as an assistant auditor general. The same as that assistant auditor general, and he was posted to Calcutta. Luckily. And at the same time, Calcutta also started the first research institute in India, which is called Indian Association for Cultivation of Science. Raman's interaction with professors, and there was no professor at IACS, it was only an association of a number of people, a number of this thing. And his association with this IACS brought him closer to academy. And he spent a lot of time in academics, and then that is when he had also published more papers, became more close to European science. I don't take names because all these names, etc., you can find in Wikipedia. Okay, so this detail you can read in detail when it is when you are at leisure. Here, actually, story of Raman is a little diversion from what I wanted to tell. I will quickly and. Raman, after 10 years of service in this, Raman gave up his job, became a professor in ISCS, and taught in the school colleges only to study students, MA students only. Today, MSc is not there, so MA students only. He had a lot of nice students. It is during this time he gave up his job as a civil servant and joined professor. Not only that, his salary became half. He didn't mind that. So he had a idea in his head right at that time and started working on light. Light was one of the very important phenomenon which was being studied, and the experiments were being carried out in order to only verify theories, not for making instruments, etc. So Raman got into that and started studying about spin of light, and he has wonderful papers on how the spin of light is 1, and +1 and -1 gives you finally a 0 spin. All those papers he has published. And when somebody asked, oh, now you left a big job and joined this one, what next? Raman was very confident at that time. Maybe Nobel Prize? Yes, he did get a Nobel Prize in the year of 1928, 30, I think 32. Okay, so this is a picture of Nobel Prize winning people along with him. This is Raman, and this is Fischer. Fischer is a German scientist who had analyzed the pigments like chlorophyll and bile pigment. For that, he got the Nobel Prize. And Landsteiner is a doctor or a physiologist. He got the Nobel Prize for blood typing. He typing. And this is Sinclair. Is an American novelist. He got in literature. This I've already explained to you. This thing, and it is in this time when Raman came into science, the science was almost finished. Everything was over, right? So still Raman had his stand. It almost all the time, the situation is like that. At present, although the situation looks very much similar. Okay, so what is the situation now? We have talked about Raman quite a lot. I have talked about Raman quite a lot, and you can find a lot of information more from this thing. But let us look at the situation, how it is now. What is the world we are in now? Okay, I think there is a jumble of advanced public physics. Okay, I think I am going this way. Now, this is a world where knowledge is free. Unlike Raman's time, you have to go to a college, take a degree, and then only people recognize. Now it is not so. Even now people go to college. Okay, I'm talking in a college national day, but still I'm saying this. But basic things in knowledge and itself for the modern world with what is available in open universities like Coursera, EDX, and Udemy. They will teach you a specific topic and take you to the frontiers how the action is. Right? You don't just find out, you can take it, it's all in the form of a mobile. Wikipedia is open. You know, Rabindranath Tagore said in the freedom, in the heaven of freedom, knowledge is free. The world is not broken up into fragments. Okay, the world is not broken up into fragments. Now, the world is not broken into fragments. China is a little bit still holding on. But other countries you can reach. I have learned quantum optics as a student. Polytechnics, one of the best. From one teaches Alan Aspect. He's on top of quantum calculation, quantum optics. And he teaches online. So from him, it's a very nice optics. Go to Coursera and look for as Coursera, I think Coursera and Align Aspect. Such people who has been there enough, just waiting for their time. There's such kind of scientists, you can learn from them. So knowledge has become free and it's available to everybody, right? And large databases are free. Nominal charges or just nominal charge. Or if you're associated with the company, ask the company to pay and use it, right? All journals are online. So anybody discovers anything, it comes online within 3 months, 4 months, as soon as it is reviewed. Unlike before, after 3 years, 4 years, it will come in print somewhere, and then by the time it reaches you only in ship or in plane, if you're lucky, it will comes in plane. It's years. Here it is within 3 months. As soon as the publication is, the next minute it's on your table. It is not just sufficiently there. It is not, does not stop there. All is available free. It's a very young, beautiful looking Serbian woman by name Alexandria Elbakian, owns a website called Ski Hub. It's written here, Ski Hub. She makes all the published document, whether it is in a journal, whether it is anywhere else, available free to everybody who visits this Ski Hub and gives a DOI in that field. You just type the DOI in the text. You will get whether it is published under this thing. And her point is knowledge is free and there is already a sufficient. You see how a social worker or an activist pushes the front of innovation, and this the law already exists. The journal is supposed to give their papers free for education, for academic purposes. I'm making use of that law. I'm making this journal available for those who want to read it. If the person makes use of that journal and does not cite, that is his problem. He will have to be punished, not me. But this is available from my side free. She's being prosecuted in India by a few of the middlemen, Amazon and such people who are selling these papers. Obviously, the matter is in the court, so we don't have to discuss too much. But I support her effort and I make use of her site a lot. And it's a wonderful site. Okay, this is where the knowledge is free for you. Okay, it is your choice in which direction you should go. Like people say, knowledge is not vast. Knowledge is very specific. It is the ignorance which is vast. So knowledge is like that simple small flame of that candle. That just removes the ever-filling darkness from the room. It's just only a small flicker that you should understand. This is a flicker. This is contained only this much. It is not infinite. It is finite and contained in our brain. So it is just a matter of hard work and perseverance and motivation to go in a direction that you want to and get this knowledge where it is free. And remember, people all over the world are doing it. Even you are doing it. I know that. These days, students are very well versed with their mobile. 80% to WhatsApp, but otherwise, they are also making use of it for obtaining knowledge. The second part of it is one world without boundaries. This is again Rabindranath Tagore's heaven of freedom, where you can create your own world. Hello? Okay, where
Yes,
you
sir.
can, yes? Is there a question or something? No, right?
No, sir.
Yeah, where you can create your own world. It's WhatsApp, right? You can create your own world in WhatsApp. Meet experts and discuss matters of concern. Can you tell me if you have traveled or on phone, spend a huge amount of money. Now just blog. There are blogs for everything. There are blogs which says how to use Linux, and there are blogs which says how to hack somebody else's computer. Okay, I mean, I have not seen a blog which makes an atom bomb, but okay, it's better not there. Okay, so or you can go and see what is happening in some far off unconnected country and say I like this or I dislike this. Oh wow, this is very bad. All those things we can say. We are a world without boundaries. Two of the criteria put down by Rabindranath Tagore has come true in this new world where we are living. Where do we go from here? Before we go into that point, this is the revision I said I will make on a picture which was this before when I'm patenting laws I was talking about. This is not, this is patenting law as it is. The law, the science driven. It is a part of the people who are sitting here driving the entire system, both in all directions. They are driving people. That means the law and society. They drive the technology. They drive math and science. They drive the services to people. And why are developed? It is into this world that you have to enter. Go there and take part in it. It is not sufficient to sit on WhatsApp and forward whatever came. Once in a while, you make your own video and put it on. That's an innovation, right? When you put it on, if you're a science student, try to learn and try to tell your idea in science. When you are trying to tell, your own mind will control it and make it good. When you want to tell something important. Right? Something important that your mind will take care of. Who can do this, sir? I'm only a student. No, you're not only a student. You are a student. That's more important. There is nothing like only a student. At the age of 16, Raman could publish a paper in Nature. Okay, Raman was extraordinary. And he was not extraordinary before he published the paper. He became extraordinary after publishing the paper. Here I wanted to give you an experience, very bad experience I had when I was very young and looking for a job. So one of the jobs which came was as professor in UGC. I went to Delhi for an interview. And I had just finished my PhD in TIFR, and I had left and I had worked in IAC also. And now IAC 6 months RA position was a stopgap, and I had to find a job. And so I went to Delhi for the interview, and in the interview, they asked me, what is your proposal? What do you want to do? So I explained to them, I have done this much in using NMR. I have tried to look at the mechanism of superconductivity. So I want to continue that work, and then I want to get a machine, and I want to work in IAC. I will be working in IAC, only take care of my salary. One of the interview board members asked me a very nasty question. He asked me a question, big scientists are trying to solve this problem. Think you will solve the problem? My question at that time was not to reply. But I tell this story to everybody because such people exist everywhere. They don't understand what is innovation, what is science, what is knowledge, nothing. Why? Look at the question. Big scientists are trying this problem. Have any big science produced any big innovation? You tell me. They became big scientists after producing the innovation. Einstein was a bad student, not because he was not intelligent. He was really basically lazy. He didn't work hard. He was a patent clerk when he first published his paper. So the biggest scientist, we all think, patent clerk when he published his paper. He became big after he published paper, not before. So it is not true that big scientists are producing big science. No. It is a scientist. It is a sincere scientist. A person who's interested in pushing himself and the science with him is the one who will invent you. That's the students who are coming to the hem of their life and want everything the best. You can arrange it for yourself. Get into the system. and get to know it and push it further. That is the only way. Now, I wanted to tell you where all this thing going, and okay, I will. These are some important things you might know already, but I thought I should not leave it without saying. Microsoft Azure is a company which gives you powerful computers at your fingertip on your laptop or on your mobile. I don't know about mobile, on laptop. You'll have to pay, right? If you want to use extraordinary facilities there, you have to pay. But if you are innovating, you will have money or find a way, right? Or find a way to work. If there are some, you have a large amount of data to find the trend or use artificial intelligence, etc. Microsoft Azure, Amazon Web Services are very nice, wonderful computers. You can have computers of a number of processors and terabytes of memory with computing powers and softwares that are available. And within a fraction of a second, you can make a computer of the configuration you want. I want 250 processors and 2 terabyte memory and so much of this software inside that. That is Linux or Windows software inside that. The computer will be ready within minutes. Okay, where it is, how it is running, where it, don't ask those questions. It's there. It's available for you. I was on one Google Computations. That also is another one which I have not written. I'm sorry about that. Google Computation opened this, and it was free for 1 year. I made use of that. Okay, and then they wanted further, and I could not bring my my work to the level where I could pay for it. I will do it sometime. Still learn that. So it's the world not tips, literally at your fingertips. Where is innovation? Where is that? What are the known innovations people are looking for? There's something called dark matter, understanding the universe. Universe 60% is missing its mass. Okay, even universe is more obese than we think it is. So people are looking for this dark matter, and they come up with various different dark matter. And the recent Nobel Prize is given to a person who observed the black hole at the center of Milky Way galaxy. Black hole is not the dark matter. Dark matter is alternative energy. That is one way I understand dark. Bottom line, it is not understood. But there is dark matter. Quantum computation. Have quantum computation taken over? Yeah, in the previous slide I showed here, IBM computing facility has an open cloud system for you to use quantum computing. It gives you simulator as well as the real-time backend. First you run your program on the simulator and see if it will all run, and then give it to a quantum computer, which will do your calculations, which will manage your data at nearly again in a it is not available for all purposes. It's available for it is like the growing part, the budding part of the plant. That is where the growth is. Quantum computation is a wonderful business and a wonderful scientific endeavor. Quantum teleportation, also people have started moving one spin from one place, and they have communicated between two spins without any, quantum communication, which is supposed to break the barrier of the velocity of light. It is there. It is also open. It is to get to go near them to work. It's also even now difficult. But if you are making your way, you are making your headway. If you know you are going in the right direction, please work on your own. You will find a huge number of opportunities of various levels. I've given you examples from the helm of science, but that is not the only way. Not everybody can go and sit there. Not everybody can become Sundar Pichai and we can sit on the top of Google. Only one person can sit. But there is a second huge number of very important. Their name also will come up. Their contributions are as important as others. and as interesting as that. So there is a large amount of possibilities, etc. So then let us go to the last one. Here I have put, as you can notice in the entire talk, I limited myself to good extent to physics and a little bit on chemistry and no biology at all. I have talked. It is my weakness, and the amount I talked about on the physics, the opportunities, etc., you multiply 10 times, so much opportunities available in chemistry, even for physicists. Okay, calculation, possibilities available for physicists also, chemists also, biologists also. The recent biology Nobel Prizes are for RNA discovery. Rama, I forgot the name. See, I'm very bad in remembering names. So, cure for cancer, medicine against virus are at the hem of the activities, but there are thousands of millions of other things which are slightly below supporting these fronts. Right? The front of the wave is just the appearance, but the tsunami is the bulk of the matter. The bulk of the matter is huge place for everybody in that wave of science and future. Conclude my talk by take too long a time. Sorry. Truth at a step closer to the creator. This is true for science too. The real happiness of the world at your fingertips is when you involve in its creation by both understanding and contributing. What makes this place better for come. Thank you very much. Did I take too long? You could have given me a warning for.
Thank you, sir.
No.
For the time. Only now I looked at the watch. Looks like I took too many diversions. That's why it took a long time.
It's okay, sir. It was a very nice presentation.
Okay.
Lot of
Thank
information.
You. Started. Yes, I suppose they were useful information, because in this world of information, there's too much of it. To get the useful one, it's difficult.
Yes, sir.
So 1 hour 15 minutes. Okay.
Okay.
I can invite 1 or 2 questions also, if it is allowed, and if there is time, we can have questions.
Thank you, sir. We had a great time listening to you. Now we are providing an opportunity to enlist your queries related to our topic of concern. You can unmute and speak openly, or can text your queries in the comment box, and we will be discussing it one after the other briefly.
Yes, there are internship opportunities, but for the current situation now, there is also before internship opportunities. I want to tell you, there is also a recruitment process open for research scholars. They are planning to take a large number of research scholars. I don't want to give a number because I don't remember exactly the number. So the large number, I think the process will be going on to March sometime. So search for the process under in Homi Bhabha National Institute, HBNI. I will type it here. Homi Bhabha National Institute. Okay. This is a research scholarship for 5 years. It's a very well paid research scholarship. So, and you will be working in one of the most advanced centers. That is one opportunity. Internship opportunities are there for third year BSc students onwards. Third year BSc, first and second year MSc. We normally prefer second year MSc students, or those who have just finished first year, going to the second year MSc students, because the kind of work will make meaning people both ways. We can work. Last year there was a student with me. Yes, you can write asking, sir, I want work on solar cells. I'm not working on solar cell. I work on superconductor. So I take your application person and can be processed from there. It all depends on whether that person is ready to take, and the BARC has not taken too many interns by that time. There is also a number of it's but very large, so you don't worry about it. Okay, there is a brief outline of research activity carried out in BARC. BARC is a large institution. A good portion of it is basic sciences, physics, chemistry, and biology. These are basic sciences. There are 3 groups on this. And this physics has nuclear physics, solid state physics, astronomy, and atomic and molecular physics. These are the basics. Astronomy, we have a laboratory in Leh and Ladakh for studying the cosmic rays and things like that. And nuclear physics studies nuclear reactions, and they have collaborations abroad. CERN and LHC and all, they have collaborations. And that is nuclear physics, because nuclear physics now has become very expensive. Modern physics is with large collaborations like that. So CERN is one place. I mean, there are other Fermi Lab and such places in America also. We have collaborations. This is physics. And chemistry. Chemistry works on 2 parts. One is radiochemistry and then other is normal chemistry. Both chemistries are very well advanced, and they publish a large number of papers. And biology works on radiobiology also. Other than radiobiology, they also work on a lot of other things, microbiology and molecular biology and physical biology and calculation biology. So that is the kind of basic science part. The other major part of BRC is engineering. So if you are a little bit application oriented, even physicists are appointed in engineering groups. Like engineering groups are mostly reactor operational group, reactor maintenance group, and special, electronics group, instrumentation group. The instrumentation group has a lot of scientists, not engineers only. So that is the other channel is apply and join BARC as a scientific officer, like Raman did, right? Raman did not have an institute at that time to join like this. Now the central government batch-wise selection also takes scientists and appoints in BARC, IGCAR, RRCAT, Indore. IGCAR is in Kalpakkam, Tamil Nadu. RRCAT in Indore, Madhya Pradesh, VCC in Calcutta. There are many other places where DAE, Department of Atomic Energy, runs their institutions. Yes. That is the answer to, sir, can you give a brief outline of research activities?
Is there any more queries to be asked? Thank you, sir. Now we are moving on to the end of the session. Kindly fill the feedback form provided in the chat box for receiving the certificates. Now I welcome Anakha Biju, Student Coordinator, for delivering vote of thanks.
Respected principal, our distinguished resource person, our beloved head of the department, and dear staff coordinator, and all my dear teachers and my dear participants. Today, I feel honored and privileged to propose a vote of thanks to all who made this function a reality. First of all, I would like to thank God Almighty for making today's occasion a resounding success. I take this opportunity to thank, even though in her absence, our beloved principal, Sister Cherkusman CMC, for her valuable support and encouragement. Now it's my privilege to extend our sincere gratitude to our Honorable Resource Person, Dr. A.K. Rajarajan Sir, Scientific Officer in Baba Atomic Research Center, for accepting our invitation and giving a talk on the topic History of Scientific Innovation. The section was very interesting and informative and was full of knowledge. It gave deep insights into the topic, and I'm sure that the precious knowledge given by Sir through his talk will help us in our studies as well as in our future enjoy. Once again, I would like to thank Sir for giving us your precious time from your busy schedule and enlightening us with our knowledge. And now, let me express our heartfelt thanks to our beloved head of the department, Dr. Marina Aloysius ma'am, for her immense support and providing a stimulating environment for such educational program. Thank you, ma'am. Next, I wish to express my sincere thanks to our staff coordinator, Dr. Sherin Thomas ma'am, for her constant encouragement, support, and guidance for making this event what it was. Thank you, ma'am. Also, I would like to extend my hearty thanks to all the teachers in our department and non-teaching staff for their valuable support and guidance. Today, I take this opportunity to thank Academy of Physics teachers for giving us the resource support for organizing National Science Day Celebration 2021. And this is the time to thank each and everyone for accepting our invitation and being a part of this webinar section. Thank you all. Last but not least, I would like to thank all my dear PG friends for their dedication, teamwork, and untiring effort and making this occasion a successful one. Once again, I am thanking you all. Thank you.
Thank you, dear Anitha. We are extremely grateful to each and everyone who attended this session and made it a huge success. I once again thank our resource person, Dr. A.K. Rajarajan sir, all our faculty members, and all the members who attended this talk on behalf of the Research and Postgraduate Department of Physics, Assumption College. Thank you all
I'm
for your
also
presence and patience. Have a great evening.
I also thank all of you for a wonderful opportunity for me to interact with you. My email ID is available with the teachers, and please make use of it to contact me to get any information or any help from me, or even, I mean, you have wonderful teachers, you don't require teaching from me. So you can always contact me for any use. Thank you very much.
Okay. Thank you very much, sir.
Yes, then
Very nice meeting you and hearing
it's
you.
nice meeting you. Please direct your students to BRC if they want to do this project work, etc. Please, I will find the appropriate person and put them with it.
Sure, sir.
Okay, so
Okay.
shall I leave?
Thank you, sir.
Shall I leave then?
Yes, sir. Thank you, sir. Thank you so
Okay,
much.
bye. Bye.
Okay, bye.
Hi, bye, sir. Thank you.